How do I spray viscous fluids with the FlexFlow electronically controlled nozzle system? Now, the FlexFlow system normally controls our electronic nozzles such as the EHP or EHPI. These nozzles have an integrated solenoid valve that allows them to be cycled on and off very rapidly, and this offers a great degree of control over the sprays that we can get out of them. However, at the end of the day, despite having the integrated electronic valve in there that gives that control, the spray is formed by a simple hydraulic spray nozzle tip. And this can pose some limitations on types of fluid that can actually be sprayed. Fluids that have a viscosity higher than water can be difficult to form good spray patterns at sensible pressures with hydraulic nozzles. We start to run into some limitations here. As with hydraulic nozzles, viscous fluids will affect spray pattern. The more viscous the fluid, generally speaking, the lower the spray angle will be. So if we have a spray angle of 90 degrees with water and we have a more viscous fluid, maybe you'll get only a 60-degree spray pattern out of that. And eventually, the spray pattern will be so reduced that you won't be able to form a proper spray pattern at all if that viscosity gets too high. Now you can overcome this by increasing the pressure that you spray at with the hydraulic nozzle. So it's easier to spray viscous fluids at higher pressures. You can start to form that spray pattern better if you can increase the pressure. But you will also start to increase the flow rate with the pressure. So we start to run into some problems. If we need to get sort of relatively low flow rates of highly viscous fluids, we may have to have a fluid pressure that's too high to form the spray pattern, and then we're overspraying and getting too much fluid coming out of there. And also, generally speaking, the smaller the orifice size, the harder it will be to spray a viscous fluid. So if we're running into the situation we had before, where we've got a viscous fluid, we need a 10-20 bar spray pressure to actually form a proper spray pattern, but that's giving us more fluid than we actually need, then perhaps we can reduce the orifice size, get that flow rate down. But then it becomes even harder to form a spray pattern with that viscous fluid, and so maybe we have to increase the pressure even more, and we're kind of into a vicious cycle there. The point is, with simple hydraulic nozzles, we are limited in the viscosities that we can spray, because the only thing we can actually do is to start spraying it at higher and higher pressures, and then that can affect the flow rate. Now, with the electronic nozzles, we can actually compensate for this in some ways. We can use pulse width modulation to reduce the flow rate without reducing the pressure. So we could spray at those higher pressures and get more viscous fluids flowing through them. And then if we're overspraying because we've increased the pressure too much, we're getting too much flow rate, we can pulse the nozzle on and off very, very rapidly and reduce that flow rate down. We do have a greater degree of viscosities that we can actually get through these nozzles at lower pressures. However, a limiting factor on the electronic nozzles is that they are limited to the pressures at which they can spray. The reason for this is that the solenoid valve that shuts the nozzle off is very sensitive, deliberately so. It's a low resistance solenoid in there because we want to rapidly cycle it on and off. So we're limited to the amount of pressure that it can actually hold back. Yes, we can get certain viscosities through these nozzles, more so than with a basic hydraulic nozzle in some situations. But if we really have to spray them at very, very high pressures, much above sort of 20 bar, then the electronic nozzles are just not going to be able to cope with that either. So yes, you can get viscous fluids up to about 25 centipoise flowing through these electronically controlled nozzles, but it can be tricky to set up, and there are limitations above that on what we can actually spray through these electronic nozzles.